Common multiples. In this video clip, we're going to explore the idea of what a common multiple is, and this follows on from the introduction video that we explored multiples as a concept. Once we explore common multiples, we'll also be able to unpack what the lowest common multiple is, which is commonly asked in test questions, but is also a useful skill that is required, particularly when dealing with fractions. So let's start with multiples of 5, which is where we left off in the introduction to multiples video clip. So the multiples of 5 we discovered were 5, 10, 15, and 20. And of course, we could go 25, 30, and so on for infinity. So it's all the 5s in the skip counting pattern that we could come up with if we keep adding another multiple of 5. Keeping these on the screen, I am then going to have a look at multiples of 2. So multiples of 2 is a similar process. We can have one multiple of 2, which is 2. Another multiple of 2 would make 4. If we keep adding multiples of 2, we'd end up with 6, 8, 10, and of course this could keep going on forever and ever and ever. So in the interests of comparing the multiples of 5 to the multiples of 2, let's just continue on the multiples of 2, even though we're not showing it using the counters. And that, of course, would lead to us having 12, 14, 16, 18, and 20. And we can keep going again and again and again for infinity, but having this extra set of multiples of 2 noted down is going to help us in our next step. Now we can remove the counters from the screen, and we can just clearly see that we've got our multiples of 5, which are 5, 10, 15, 20, and so on, and our multiples of 2, which are 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and so on. And let's now look at this idea of common multiples. What is it we actually mean when we're talking about common multiples? Well, all we're interested in is which ones do they have in common. So multiples of 5 and multiples of 2, which ones do they have in common? Well, they don't have 2, 4, or 6 in common, nor do they have 8 in common. Because if I look at 2, 4, 6, and 8, they're multiples of 2, but they're not multiples of 5. So they don't have those in common. They don't have the multiples of 5 or 15 in common, because although they're multiples of 5, they're not multiples of 2, so they don't have those in common. However, they do have the multiple 10 in common. And we can also see they have the multiple 20 in common. So they have common multiples of 10 and 20. Of course, if we kept skip counting these multiple patterns out, we would find they also have the number or multiple of 30 in common. The multiples 30, as well as 40, 50, 60, and so on. So they're actually infinite multiples that these two have in common. So in the 2s and the 5s, they have an infinite amount of common multiples. But they also have many that are not in common as well. What we are interested in usually is not just which multiples they have in common, but we want to know which one they have in common that is the lowest we can find. And of course, that's just a case of finding the first multiple that's in common, or which will always be the lowest one, and in this instance that is 10. So this is our lowest common multiple, so we would call it as such. It's the lowest common multiple, which sounds fancy and often leads to confusion, especially when it's also at times referred to as the LCM in an abbreviated fashion, and can also be quite off-putting if this was in a test paper where a question just point blank asks you what is the lowest common multiple of 5 and 2. Sounds pretty sophisticated, but it's a matter of just unpacking what exactly the question's asking. So we're interested in multiples, we know what those are, which ones are in common, and what's the lowest one.